Hey guys, want to take a look at metrics today. Metrics is the chapter we're going to start with this morning, so we're going to take a look at chapter 8 in your book. Chapter 8, for those of you guys who are following along, does start on page 185. We are actually going to begin, in this part of the chapter, we're actually going to begin on page 188. So I know the chapter itself starts on page 185, but we're going to take a look at page 188. Metrics is just simply another measurement system. You guys have already been exposed to one type of measurement system called the household system of measurement. We looked at that in chapter 4 when we did the proportions and we were looking at things like teaspoons and ounces and cups. In this chapter, we're going to take a look at metrics, which is a system that a lot of just different countries use. But in healthcare, it is the most commonly used system of measurement that is used in healthcare. I'm sure you guys have already seen quite a few of these, as a lot of our medication labels, dosages are measured using the unit milligrams or sometimes grams or micrograms. If you go home and look at any of the medications that you guys have in your medicine cabinet, you guys will see that somewhere on that label, it will say somewhere on there that there are so many milligrams per, say, tablet of medicine in that bottle. If it's a liquid medication, sometimes it's so many milligrams per so many milliliters, and milliliters is another metric unit. So just a lot of different places where we're going to see that, and we're going to see that later on when we take a look at dosage calculations too. So starting with the metrics are actually great because they're super, super, super easy. On the top of the screen here, I've got the chart that you guys also have at the very top of page 188. Now, metrics are so easy because it simply just involves a movement of a decimal. And I'm going to show you guys how easy that can be. But as we go through this chart that's on page 188, I want to explain to you guys in a little bit more detail why it is as easy as just moving a decimal. So I want to make sure you guys understand metrics a little bit more before we just start moving those decimals. So the chart at the top of page at 188 is the one that you guys see on the top of the screen there. So you can see across the top the different units. And you all see these little dashes, and I didn't put them on the screen. I didn't do that, but you can see next to kilo, it has a little dash. Next to hecto, there's a little dash. Next to deca, there's a little dash. There is not one next to base, but there is next to deci, centi, milli, and micro. All of those have a little dash behind it because it's showing that those are different prefixes that are used to be put in front of our bases. Now the bases you guys have right there in the middle. I'm going to touch on these bases just a little bit. Metrics are centered around 3 different units, and that's what we're calling our bases here. They're grams, meters, and liters. All of these different prefixes that you guys have on the top of the screen, those prefixes are simply just added to those bases to change the size of them. And I'm going to explain that. But let me explain what these bases are first. All these 3 bases, everything is centered around these 3 bases, and it simply just depends on what it is that you're measuring. Grams, the first one you guys see up there, grams are used to measure a weight of something. So how heavy something is. So grams, we may choose to use grams or milligrams, and that's where the prefix milli is going to come in. The prefix micro may come in when we're measuring drug dosages. When we're measuring how many milligrams or micrograms are contained in a certain amount of medication. So we're going to see that grams and kilo, that prefix all the way over on the far left. Kilograms will be used to measure the weight of a patient. So again, it just depends on what it is that we're measuring to see where we're going to use these different prefixes and these different units. Now, meters, guys, meters is used to measure a distance, or a length of something, I should say, I guess. But the distance between 2 cities is a very long measurement, but we would use kilometers, or sometimes pronounced kilometers, to measure that type of distance. We may use millimeters to measure something really, really small. You guys have probably heard the prefix centi come up before because centimeters are used to measure another small unit of length. And then lastly down there, and so we'll talk, like I said, we'll talk more about this here in just a minute. But liters, lastly, liters is used to measure a volume. So you guys, I'm sure, have all seen 2 liters before. 2 liters we can buy in any drugstore or grocery store, I'm sorry, where we're going to be able to buy Coke products or Pepsi products or something that, or off-brand, but of those 2 liters, that is literally just 2 liters of this measurement of that liter measurement that we're looking at here. Sometimes different prefixes are added, like milli if we're measuring a small amount of liquid. A lot of the Coke bottles that you can get out of vending machines, somewhere on the side of that bottle, some of you guys may have some in front of you right now, if you have a water bottle or a Coke bottle or something that you got out of a vending machine, it will say how many milliliters are in that. Not just how many fluid ounces are in that bottle, but in parentheses it sometimes says what that equates to in milliliters. So liters are used to measure a liquid, so how much liquid we have of something. So again, everything is centered around these 3 units. It's just those different prefixes are added to change the size of those a little bit. So let me talk about that in a little bit more detail. Let me get that out of the way for a second. So now that you know what our prefixes or what our bases are, grams, meters, and liters, they all measure 3 completely different units. But as we're going through those, I want you guys to picture, as we go through these different prefixes, I want you guys to imagine a meter. A meter, as you guys I'm sure have seen a yardstick before, a meter is very close in size to a yardstick. So imagine I've drawn this goofy looking line up here, this block up here. Imagine we're picturing a meter. Like I said, it's about the size of a yard. So imagine holding your hands out in front of you, a little bit wider than across your body. You know, that's about the length of a meter. Now, that meter, what we're going to do, that's one of our bases. But as we go through these different prefixes, I'm going to show you guys how that prefix changes the size of this, one of our bases here. But we can do the same thing by putting these prefixes in front of any of our bases. But I'm going to start in the middle of that chart on page 188, and on the chart on our screen here, base is right there in the middle. But I'm going to start by going to the prefixes to the left of that. So I'm going to start with deca, then move to hecto, and then kilo, and I'm going to explain those a little bit further. So you notice that underneath the next line on our chart there says that we've got the value of those. I'm going to explain the value, and then we're going to really not do too much with them, because again, the conversions that we're going to do in this chapter just involve a movement of a decimal, but I'll explain that. But there's a reason why I want to show you guys these values first. You'll notice that deca has a unit of 10. Well, if I could write today. Has a unit of 10. And what that means is, if I add the prefix deca to the unit meter, and we call it a decameter, what that would be 10 of those meters lined end to end to one another, and that would be a decameter. Would be 10 of these meters lined end to end to one another. So meaning we might use a decameter to measure the distance between something that's a lot longer of a distance. Instead of, we may use meters to measure between, say, you and the front door of the classroom. But between you and maybe the building across the street, so say across Lynn Station Road, that might be a longer distance, so we may choose to use decameters in that case. Same thing with the prefix hecto. Hecto has a value of 100, so adding the prefix hecto in front of meter would mean that a hectometer is 100 of those meters end to one another. A hectogram would mean I have 100 grams, and a hectoliter, so again, imagine a 2 liter, cut that in half, and that's 1 liter. Now imagine I have 100 of those liters, or 50 of those 2 liters. That's a hectoliter. Whereas the prefix kilo, all the way down there on the end, has a value of 1,000. So again, adding the prefix kilo in front of meter, we would call that a kilometer, as a lot of different countries are on the metric system, and they use kilometers in place of what we use to measure longer distances. We're on the household system, and we use miles to measure between, say, different cities, or when we're going to somewhere else in town and it's say 4 or 5 miles away. Countries that are on the metric system would say that they're going 4 or 5 kilometers away. It's not an exact equivalent. 1 mile is not the same as a kilometer. Excuse me. However, it's very, very close in relationship, and that gives you an idea of just how long a kilometer is. Kilo in front of the word gram. A kilogram we'll use to measure body weights when we get to that in just a little bit. Okay, so now let's take a look going the other way. And like I said, I'm doing this kind of quickly because I'm going to show you just a real easy way that we can convert these. The prefix that's to the right of the word base, I'm looking at the prefix deci. In your book, it says a value of 0.1. I want to look at that in terms of fractions for a second. 0.1 is the exact same thing as 1/10 if we were to convert that decimal into a fraction. And the reason why I show you that as a fraction is because what deci means is that we're now cutting up this base. If I add the prefix deci in front of the unit meter, what I've done is I've cut this meter into 10 equal sized pieces, and one of those would be considered a decimeter because it means 1/10 of a meter. A decigram is 1/10 of a gram, and so on and so forth. Centi, 0.01 is the same thing as 1/100th. So again, 1/100th, now we're cutting this meter into even smaller pieces. So obviously I can't draw that on here, 100 pieces, but one of those is considered a centimeter. So really on this entire meter, 100 centimeters fits on here. That's the same thing. 1 meter is the exact same thing as 100 centimeters. Milli has a value of 1/1000th. Okay, so let me draw this a little bit lower here, 1/1000th. So a millimeter, adding the prefix milli, would mean that I have 1/1000th of that meter stick there. If I have a milligram, as again we use that a lot in drug dosages, a milligram would be 1/1000th of a gram, and a milliliter would be 1/1000th of that half of the 2 liter. Again, that 1 liter, 1/1000th of that, a very small amount of liquid, is a milliliter. There's 2 X's there, and I'm going to explain those 2 X's in just a second, but micro has a value then of 1/1,000,000th. That's supposed to be a comma. 1/1,000,000th. Oh, I forgot the 1. 1/1,000,000th. So meaning if I took this meter stick here and cut it into 1,000,000 pieces, that'd be really, really hard to see those different pieces. However, one of those would be a micrometer. If I took a gram and cut it into 1,000,000 pieces, a microgram is 1/1,000,000th of a gram. So a very, very, very small unit of weight, whereas a milliliter is such a tiny amount of liquid. That's what a microliter is that we've divided that liter into 1,000,000 little droplets, and one of those would be a microliter. So that's what these prefixes represent, is they're showing us how we could add these prefixes to these bases and it would change the size of them a little bit. What's going to happen in this chapter is I'm going to take one of these units. So I'm going to go to this picture for just a second. One thing that you all may be able to just do in our head here. Let's say if I know right there that 1 meter is equivalent or the same thing as 100 centimeters, if I asked you guys, if I had 5 of those meters, would you guys be able to tell me what that was in then centimeters? If 1 meter is 100 centimeters, then 5 meters would be 500 centimeters. So what we can do here, yes, you could know all those knowns and just memorize that. However, there's a much easier way to do this. Okay, so pretending we don't know the answer there should be 500. There's a reason why I showed you all these values, and all these values up there you can see are based on units of 10. Well, something else that's based on units of 10 would be our place values. All of our different place values, again, are tens, hundreds, thousands, and so on. So the reason why I showed you all this is so that you guys can see that really conversions within the metric system are simply going to involve a movement of a decimal. And so let me pull this up here and get rid of all these values real quickly just to get these out of the way. So let's go back to that question again, pretending like I don't know the answer to the question. We have 5 meters. I'm just going to use the abbreviations for these. 5 meters, and I want to know what that is in centimeters. Okay, so 5 meters, and I want to know what that is in centimeters. So what I can do is I can use that chart that you guys have on the top of your screen and on page 188. I can use that chart to show me how to get to this answer. What I'm going to do is I'm going to use it like a map. A map that shows me where I start and where I'm going. What I mean by that is in this question, the question is telling me that I have so many meters and I want to convert that to centimeters. So really kind of focusing on our prefixes here, what I have is where I'm going to start on my map. And I have one of my bases, meters by itself. I don't have any prefixes in front of that. So that's one of my bases. So that's going to be my starting point on my map. What I'm trying to convert to is where I'm going to end on the map. And I'm trying to convert to now the unit centi, or the prefix centi. So that's where my end point is going to be on my map. So I'm trying to go here. So what I just did on my map, when I'm going from base to centi, you guys will notice I've gone to the right on my map. What I'm also going to do is count how many places I had to move to go from base to centi. So to go from base, to get from base to deci, that's one movement. And then to go from deci to centi, that's a total of 2 movements. What my map is going to tell me with the movements that it takes me to get to my end point and the direction that I go, so meaning whether I go right or left, in this case I went right, that's what I'm going to do with my decimal. So since my map told me to go 2 places to the right, I'm going to do exactly that with my decimal, and that's where I'm going to get my answer. So with 5 being a whole number, the decimal starts right here behind it. Map told me to go 2 places to the right, so I'm going to move it 1, 2, and I'm just going to fill these empty places with zeros. And so I don't need these little squiggly lines anymore. That's where that 500 came from. The decimal, since the decimal ended here at the very end, we don't have to write it since there's nothing behind it. So that's why this converts to 500. It will work every single time, no matter what you're trying to convert to. So let me get some of these out of the way here. Get out of my way. Let's see. This is not going to work. It's not going to let me do it. Oh, there it goes. Okay. So let me get these out of the way. So let me do another example. Let's say I have how about a doctor's order that says they need to take 1,000 milligrams of a particular drug. But I'm going to look and see on that label it says what it is in grams. Okay, so again, I know, guys, I'm using the abbreviation, but if it helps, I can show you this. This is the prefix milli here, milligrams. So I'll make sure I say them out loud. It just is going to take me quite a bit of time to write them out. So I'm using the abbreviations for those. And those abbreviations you guys can see at the bottom of page 188 if that helps. So milligrams to grams. So like I said in the last example, if you focus on the prefixes, what this question is asking me is my question itself, I'm starting at 1,000, not even 1,000, don't even look at that right now. The fact that I'm starting at milligrams, I'm trying to go to grams. So meaning I'm starting at the unit milli, or on my map, that's right here. I'm starting at the unit milli, and I'm trying to convert to grams, which remember grams was one of my bases. Since there's no prefix in front of the word gram, then we're going to end at base. So this time I'm going from milli to base. Milli to base is to the left, but however many times it takes me to get from milli to base, I have to count the number of places. So again, to go from milli to centi, we're going to count that. That's 1 movement. Centi to deci is 2. And then deci to base would be 3. 3 places to the left. So with 1,000 being a whole number here, decimal is going to start down here at the end. And so map told me to go 3 places to the left. 1 would put it in front of that 0, 2 in front of that 0, 3 in front of that 0. So therefore my answer is simply 1. Okay, guys, let's try another one. This time I want to show you guys where or how that micro unit down at the end comes in. Just to show you guys real quickly, just to refresh our memory on what our values were. Remember, deci was 1/10, centi was 1/100th, milli was 1/1000th, and we skipped all, whoops, forgot a zero there. And then lastly, we skipped all the way down to micro, which was 1/1,000,000th. And so you can kind of see the pattern here. I go from 1 0 to 2 zeros to 3 zeros to 6 zeros. So what's happening here is, and again, kind of think of how place values and how we count our place values. We count tens, hundreds, thousands. We don't skip to millions. In between, and that's what's happening here with these two x's, these are the place values that represent the 1/10,000th place and the 1/100,000th place. We can't just, if we're going to use this as a map, and so there's our 4 zeros and our 5 zeros. We can't just skip over place values if we're using this map as, or this chart as a map to show movement between our place values. The thing is, there's no prefix to represent that 1/10,000th place and then the 1/100,000th place. There's just no place values there, but I can't just completely skip over place values. So what has to happen is when micro is involved, I can't just completely skip those over. What I have to do is I have to move between those places. So given an example, let's say I have, I don't know, let's say 14 milliliters, just abbreviating here, milliliters, and I want to know what that is in microliters. The abbreviation for micro is just lowercase m and then the addition of that lowercase c there. So I'm trying to go from milliliters to microliters. Again, the thing to focus on when you're using this map is to focus on the prefixes. So again, I'm trying to convert from the unit milli, and I'm trying to convert it to the unit micro. So on my map, here's milli and here's micro. So my starting point is the milli and my end point is the micro, since that's what I'm trying to convert to. So what we've done is we've gone to the right, but we're going to count those x's. So to get from milli to the first x would be 1, to the second x would be 2, and lastly to micro, there's my third movement to the right. So I'm going to the right 3 places. So once again, with a whole number, we have a decimal to start with. It's just at the very end. So I'm going to take that and move it 3 places to the right, the way that my map told me. And it looks like that just ends up adding 3 zeros. So my answer here would be 14,000. So that's what happens anytime micro is involved. Now let me tell you what else is happening here. For those of us that, just looking at this, there is a different way that we could approach this. What's happening every time we move to the right? So really, just let me put that last example up there again. I went from 14 milliliters to microliters, and since we moved 3 places to the right, we ended up adding 3 zeros, and that got me to 14,000. Every time we're moving a decimal place, every time we're moving 1 place to the right on that map, we're technically multiplying by 10 with each movement. So really, it's like I went times 10, times 10, times 10 with those 3 movements. But I can actually put those together. That anytime I move 3 places, without having to, if you want to use your calculator in these, that's why I'm showing you guys these, or this method. Instead of having to, in our calculator, type in 14 times 10 times 10 times 10, instead, let's summarize this a little bit. It's going to be 14, but with each movement, it's 10 times then 100, 1,000. So really, you can put these together. Just keep adding zeros with what you're going to multiply by with every movement. So since I moved 3 times, I can just simply take 14 and multiply it by 1,000. Whereas if I was going the opposite direction, I could do the same thing. So if I say, but in this case, I'm going to divide. So if, say, I have, give it another example, just to show you guys the same method. I'm going to show you guys a different way to do it, though. But if, let's say, I have, I don't know, let's say 25.6 milligrams, and I want to know what that is in grams. Well, here's milli on my map, and here's gram is one of my bases. So that's, again, it's simply just 3 movements to the right or to the left. So I could just move my decimal 3 places to the left. Again, I'm moving by 10 with each movement. So really, that's the same thing as dividing by. That's what's happening when you go to the left. Dividing by 10 3 times, or dividing by oh whoops, I don't know why that moved. Divide by 10, 100, 1,000. 3 movements. I'm going to divide by 3 zeros. So I could just take 25.6 in my calculator divided by 1,000. Again, or you can simply just do what the map told you and go 3 places to the left. I have to add a 0 in there. Your answer should be 0.0256. We just had to fill in that extra space with a 0, and since my decimal ended up in front, it's always best to end up putting that 0 in front of that. Anytime you have a number that starts with a decimal, it's best to put that 0 in the front of it to help you see that decimal a little bit clearer. And your calculator will automatically do that for you, for those of you guys that are using that calculator. So again, here's the reason why I showed you this. There's another method that you could approach. Yes, this decimal movement method works just fine, so you could just stick with that. That's totally fine. But a different instructor that I don't know if it was an instructor here or if this is just how she was taught, but she showed me when she did this. This was years ago. She showed me this. But she said that instead of having to get this whole chart down, instead, let's just focus on the most common units. What that is, you notice that a lot of the examples we've done so far are all 3 apart. That is because our most commonly used units, and I'm going to just underline these here while we're going through these, are up at the top, kilo, our base when we're dealing with, grams, typically, meters, liters. Base is used a lot, and especially in healthcare, kilo is used a lot when we're dealing with patient body weights. We're going to use kilograms. Grams are used a lot, so for the base, grams are used a lot in medications, along with milligrams and micrograms. So milli and micro are also 2 of our common units. Honestly, you're probably never going to see hecto or deca. Same with deci. The only place I can really see you ever really needing centi is in a length measurement, measuring something in centimeters. But I don't really ever seen you having to convert centimeters to something else. So another method that you could use if you want to use this method, what she did is she took just these 4 units and said, okay, just memorize just those 4. And what she does is instead of just having them across here, yes, you could just remember that they're all 3 apart, so they're all 1,000 apart. Remember, just going to the right would be times 1,000, and then going to the left would be to divide by 1,000. So you could remember that, but what she did was she put them on a set of stairs. And she said, let's just remember this. Here at the top is kilo, here's our base, here's milli, and here's micro. So all she did was she took the same 4 on that chart and just wrote it sideways instead. And so what she said was to remember this. Anytime you have to go down 1 step, and I'm going to make a note that that's down 1 step. Down 1 step, we're going to multiply by 1,000. Whereas anytime I go up 1 step, we divide by 1,000. So, in using a different example, let's just, over here to the side, let's say any method you choose to use is up to you. If you'd rather see that decimal movement, then just simply remember that chart up at the top. You'll want to have this memorized by finals week. On next week's quiz, guys, you guys can have this on there. I just want you guys to know that you'll be able to use this since you guys are just now getting this. I will leave the stair-step and the chart up on the board for you guys. But for the final, you guys will need to have these memorized, whichever method you're using. So let's do an example again here. So let's say I have 2.6 grams, and I want to know what that is in milligrams. So using our decimal movement chart up there at the top, let me get some of these things out of the way here. So using our decimal movement chart up there at the top, grams to milligrams. We know grams is one of my bases, so that's going to be right here. And we know I'm trying to convert to the unit, to the prefix milli, so that's right here. So using the decimal movement chart, that's going to be 3 places to the right. So again, when you're going to the right, you're multiplying, for those of you guys that are doing that. But if we're just counting the decimal movements, 3 places to the right, I'm going to take that decimal between the 2 and the 6, move it once to get behind the 6, twice would put it behind a 0, 3 times would put it behind another 0, so it should be 2600. For those of you guys that are using the stair-step method, base to milli on the steps is just simply down 1 step. So all I need to do is take 2.6 in my calculator and multiply that by 1000, and you'll see that that gives you 2600. So no matter which method you use, some people think the stair-step method is just easier to memorize because you're only putting those 4 into memorization. Your book, for those of you guys who would rather see the decimal movement chart, your book on page 188 uses a mnemonic device down at the very last row on that chart. It does show you guys the mnemonic device, kiss hairy dogs but drink chocolate milk mom. It's silly, but it helps you to memorize the first letter of each of those words in that sentence. Is going to be used to help you remember the first letter of all of those prefixes at the top of our chart there. It's the same reason why we use the mnemonic device, please excuse my dear Aunt Sally. Again, helps us to remember P for parentheses, E for exponents. It's much harder to remember things that don't make sense like that, where it's just parentheses, exponents, multiplication, division, addition, subtraction. Harder to maybe remember kilo, hecto, deca, base, deci, centi, milli, x micro. So instead, if you all want to come up with a different sentence to help you memorize that, by all means, please do. But some people think that that's just as helpful, so they just use that one. And like I said, you guys will need to have that memorized by the final exam. So for next week, whether you're using the stair-step method or the chart method up here on the top, go ahead, definitely, stick with one of them, or maybe even some people use both just to double check. So guys, there's plenty of practice problems as you guys go through your book. If you guys look on page 192 and 193, going over page 194, you guys will find plenty of practice problems. You guys are welcome to practice those now, or perhaps when you guys get home. I do have a review video to send to you guys. If you guys as you guys go home tonight, I think I've already sent those to you guys at this point. So I'll make sure that you guys have that. So watch that review video. And if you guys have any questions at all, please let me know. All right, thanks.